Hey, welcome back to Beard Squid. In this video, we're going to be doing a review of algebraic operations. Now, it's a bit different to my other videos. It's not a tutorial of one topic. We're going to be reviewing a few topics, so it can prepare you for an upcoming, let's say, knowledge and understanding criterion A assessment. So, we're going to be looking at algebraic notation, as well as collecting like terms, and then algebraic substitution, algebraic product, and algebraic fractions. How I'm going to do this is just go through a couple of key concepts and then fire away with some questions and answers. And feel free that anytime you can pause the video and take some notes in your copybook so that you're prepared to review those notes. So let's start off. In algebra, the variables are included in expressions as though they were numbers. But we need to follow some rules to help us make algebra easy. And we have to agree on the following rules to leave out the multiplication sign between multiplied quantities. So for example, if we had 3 times a, we would leave out the multiplication sign. So we just leave this multiplication sign out and we can write the term as 3a. The second rule here states that to write the numerals, the numbers before any product. If we had, like, for example, let's say p times 4, 4p. Okay, so the numeral, the number should be first in any product. And then finally, rule number 3 states that where products contain 2 or more letters, we write them in alphabetical order. 3 times p times a, we would write this expression with, of course, the number or the numeral in front, and then write the variables in alphabetical order. So we have 3ap. Okay, so there are a couple of rules that we're going to be using. What I'm going to do is I'm going to go through our next key concept, which is writing sums as products. So let's just write this down. So if I had the example of, let's say, 3 plus 3 plus 3, what we have here, 3 plus 3 plus 3 plus 3, is we have 4 lots of 3. And how we can write that is basically 4 times 3. So 4 lots of 3. Okay, so writing it as a product sum of products. Let's look at another example. Variables, b plus b plus b plus b. The same way we would have 4 lots of b, and then we can write that down as 4 times b. We can write it as 4b. The same way we can write this as 12. So that's writing sums as products. Feel free at this point to perhaps write this question down and then do the questions as I put them up. Let's look at part A. We've got 7 times A times 3 times A times B. What I'm going to do first is, because I'm going to have to write the numeral or the number at the front, I might as well multiply 7 times 3. So 7 times 3 gives me 21. A times B, because A times A squared. And then times b would be just b. So we equal to 21a squared b. Okay, let's look at part B then. Part B is b times b times b. So this part here, b times b would be b to the power of 3. And then look, we've got a plus. We cannot take this as one single term because there is an addition there. There's a plus. Plus b plus b plus b. So 3 lots of b. And 3 lots of b is simply 3b. Okay, so this is going to be equal to b cubed plus 3b. Power of 3. B raised to the power of 3b cubed. And that means that there's b times b times b. Okay, looking at the third one then, or looking at part C, we've got 2 times d cubed. So 2d cubed. The reason I can't times it by the 3 is because this is negative 3. It's subtraction. This term, or this expression here, has 2 parts to it. It has this part here, which is 2d cubed, and then it has this part here, which is separated by this operation. Okay, and that operation here, it tells us to subtract. What we have is we have 3d squared. So I'm just going to write that down here, minus 3d squared. Now, very important note here. This is to the power of 3 and this is to the power of 2. They've got the same base, D and D, they've got the same base, that's fine. But because they have different powers, they are actually considered different terms. Okay, so they're different terms altogether anyway. So we can write this down as 2D cubed minus 3D squared. And be careful, you cannot simplify this anymore. The question I'm asking you is it an expression or is it an equation? Well, first thing first, we need to establish what an equation is and what an expression is. So let me just write a definition here. By the way, you can write this definition into your books, and that will be a good point of reference. You can go back and revise from this. An equation is an algebraic form which contains an equal sign. So now you can see which one of these are going to represent an equation. Okay, so these two are equations. Give yourself a little tick. Now, what is the definition of an expression? It's an algebraic form consisting of numbers, variables, and operation signs. So let's just check if that's true. Let's see if we see any numbers. We do see numbers. There's a number. There's a number. There's a number. We see numbers. Do we see variables? Yeah, there's a variable. There's another variable, and operations. Okay, here's an operation. Subtraction. Here's another operation, addition. In fact, I could just highlight this to reference number, variables, and of course, operations. So therefore, we have an expression. This is an expression, and this is also an expression. There's no equal sign, simple as that. Let me ask you if you can write this in expanded form. Here's a couple of questions. So we've got 7 times t times t times t, and of course one more t. So 7 times t times t times t times t. 7t to the power of 4. Next one, we've got 3b all to the power of 3. Just repeat the bracket. So you've got 3b, and then you've got, hey, 3b, and then 3b again. So you're repeating the bracket. Because this cube, the cube's telling you, you need to multiply this by itself 3 times. So there's 1, there's 2, and there's 3. Hey, it's going to be 3 times b times 3 times b times 3 times b. So you got 3 times b times 3 times b times 3 times b. Wow. Okay, so you get the gist of this, aren't you? Let's see if part C, you got this right. So I would have, in expanded form, it would be 2 times b times b, and then we've got minus, and we've got 3 times c times c times c. So check if you got that right. And if you did, give yourself a little tick. Consider the expression 5g plus 12gh minus 2h plus 3gh plus 4. So just consider that expression. I want to ask in part A, well, how many terms are there? Part B, state any like terms. C, we'll go with state the coefficient of h. And then D, state the constant term. Yep. And then, so if possible, simplify the expression. I'm just going to leave it to simplify. So let's have a look at this. How many terms? Remember, terms are separated by operations. So let's count how many operations we have here. Okay, we have a plus, we have a minus, and we have a plus, and we have a plus. So we've got 4 operations, and let's count the terms that we have then. So we have 5g, we have 12gh, we have 2h, we have 3gh, and we have 4. Now, what's important to know, okay, is that the sign sticks with the term. This sign should stick with this term. So if I said, hey, what's the third term of this expression? You would tell me the third term of this expression is minus 2h. Not just 2h, but minus 2h. How many terms are in the expression? Well, we have 1, 2, 3, 4. We have 5 terms. Okay, state any like terms. Ooh, so let's see what we have. We have 5 goldfish. Do we have any other goldfish? No, we don't. This is just 5 goldfish, yeah? This is 12 G and H. So it's not only goldfish, there's something else with it. Goldfish that are wearing hat. So they're not the same terms then, are they? But I've seen that we've got 12 goldfish wearing hats and 3 more actually. So plus 3 goldfish wearing hats again. So, do we have any like terms? State any like terms. We do have like terms, and the like terms we have are 12GH, and we also have 3GH. You could put 12 positive there. They're the like terms. So, state the coefficient of H. The coefficient just means the number in front of, okay? So, the coefficient, the number factor of an algebraic term, okay? So here you can see, here's H. It's not referring to this part. So H is not talking about GH, because H is just a hat, and this is a goldfish with a hat. So that's not the same thing. What we're referring to is this term here, and it says state the coefficient of H. So the coefficient of H, the numerical part, is -2. Remember, the sign sticks with the numeral. So we have here -2. That's a coefficient of H. And then it says state the constant term. Now, a constant term, the definition of a constant term is a term which does not contain a variable. Okay, so remember what variables are. Variables, I think we highlighted them in blue earlier on. So these are my variables, and you can see sticks out like a sore thumb is +4. And then when we simplify it, what we can do is we can collect like terms. So that's going on to the next part that I want to teach you or review, which is collecting like terms. So let's just start that now. So to collect like terms, we need to collect terms that have exactly the same variable. So have a look at this. This is 5G. Remember what we said? That's just 5 goldfish. This is 5GH, so 5 goldfish with hats. They're not the same. They're clearly not the same. If you saw a goldfish swimming in a tank or a pond, and then you saw 12 goldfish with hats, they certainly wouldn't be the same, would they? Okay, so let's collect like terms. We've got 5G and that's it, going once, 5G. And then we do have 12GH and then plus 3GH. So we have 12 plus 3, that makes plus 15GH. We have 2, so -2H, and then we have a constant term. So we have simplified, and the only part that we've really simplified is we've taken this 12GH and we've plussed the 3GH. Now, if this was negative, what would we do? We would minus. So we've got 5G plus 15GH minus 2H plus 4. So here's a question. Gina bought a bag with 18 apples, okay, of 18 apples. Right. The question is, how many apples are left in the bag if she eats 2 apples per day for the next 3 days? Remember, an apple a day keeps a doctor away. Gina's smart. She's eating 2 apples a day. Really what we're looking at is we're looking at the sum of the product, isn't it? So she ate 2 apples per day. So if you said we had A plus A, she ate 2 apples per day. That's the same as A plus A again. She's done that again for a 3rd day. That's day 1. That would be D2. And then that would be D3. Do you think there's an easier way to do that? She ate 2 apples per day for 3 days. So A plus A, which is 2A. That's again 2A. That's again 2A. But there's 3 lots of these. So we could just say 2A times 3. Because 2 times 3, 6. 6A, 6 apples. So if she ate 6 apples, we're not finished because she started off with a bag of 18. If she ate 6 apples, then we would say that, hey, we need to minus the 6 apples from the 18 apples that she started off with. What would she be left with? Of course, she'll be left with 12 apples. How many apples are left in the bag if she ate 8 apples per day for the next D days? If we think about it, she starts off with 18 apples. So let's just write 18A. And we know we're going to minus it. How many apples are left? It's subtraction, isn't it? It's the difference. If you look back, remember what we've done? We took the expression for the day. So for day 1, it was 2A because it was 2 apples per day. And remember what we done, yeah? We done 2 apples. So 2 apples per day, and we multiplied it by 3. 2A times 3. This was the sum of the product. So we're going to do the same thing here. We're going to do a similar thing here, isn't it? We're going to do A multiplied by D. Yeah, we're going to take this A, we're going to multiply it by the D. So we're going to say, well, that's the same as AD. So it's 18A minus AD, because 8 apples per day for the next D days. Here we go. Let me give you this question then. So simplify the following, okay? So what we're going to do is, let's start with part A. If I write this in expanded form, so 5 times x times 4 times x. So let's find the algebraic product. You can see here that I've got 5 times 4. So let's just do the numbers first. 5 times 4 is 20. And then I have x times x times x, which is x cubed. X cubed. X cubed. Remember, x plus x is the sum of these terms, which will be 3x. Okay, but remember, we're multiplying here. This is multiplication, that's a multiplication. X times x times x, x to the power of 3. Let's look at the next one. And again, it's nice to write this in expanded form. So let's write in expanded form. So because it's all multiplication, I can start cancelling out from the numerator and the denominator. Okay, exactly the same way as if I said, hey, you have 2 over 4, can you simplify that? And you would say, actually, yeah, I can. 2 is 2 times 1, and then 4 is 2 times 2. I can actually cancel out those 2's, and I end up getting just a half. The same way we can cancel out the variables. Nothing is left. So does that mean that the answer is 0 then? T to the power of 6 divided by t to the power of 6, is it 0? No, it's not 0. It's 1. Why? Because anything divided by itself is 1. How many times can t to the power of 6 fit into t to the power of 6? Well, 1. How many times does 2 go into 2? 1. Let's look at part C then. Let's just write in expanded form. You know, I could write 10, but I'm going to write 5 times 2, because 5 times 2 is 10, yeah? I'm going to cancel out the 5 with the 5. I can cancel out x with an x. I can cancel out a y with a y. And I'm left with x cubed divided by 2y squared. That's my final answer. So let's have a look at these algebraic fractions. But what we're looking at is multiplying and dividing algebraic fractions. So to multiply two fractions, we multiply the numerators together to give us a new numerator, and we multiply the denominators together to give us a new denominator. So for example, if I had a over b times by c over d, I would multiply the numerators together. So I'd multiply these, which would just give me ac, and then I would multiply the denominators, which would give me BD. So let's look at an example of division. This was my multiplication. If we have division, to divide a fraction, we multiply it by its reciprocal. So let's take the same variables. We have a over b divided by c over d. So we're going to do something that you may have done a long time ago, which was keep, change, and flip. Okay, and the flip is basically the reciprocal. So if you want a more sophisticated term, you would write reciprocal. So do a over b, and it will be multiplied by d over c, and then that takes us back to the first step, which is you just need to multiply the numerators and multiply the denominators. So let's just show that last step. I would multiply these numerators to give me AD, and then multiply the denominators to give me BC. Let's have a look at these. Okay, let's have a look at some examples. Simplify the following. Let me give you a question here. And remember, you can pause at any time and do the question before I put the answer up so you can compare with my notes. We multiply the numerators. And remember, we have the numeral before the variable, 10m. And then multiply the denominators, so 4m squared. We're not finished because we can still simplify, can't we? I could do this as 2 times 5 times m, and at the bottom I could say 2 times 2 times m times m. Let's see what we can cancel out. We can cancel out 2 with the 2, we can cancel out m with the m, and we're left with 5 over 2m. And then that's done. Let's look at part B. Remember, we need to keep, change, flip. So let's write that down. We'll do 2 over x multiplied by 3 over x. And now we're just going to simply multiply the numerators to give us 6. We're going to multiply the denominators to give us x squared. So 6 over x squared. See if you can do this one. It's 5n divided by p to the power of 2 multiplied by 2n squared over 7. So see if you can do that. 10n cubed all over 7p squared. And because there's no common factors, we can leave that as it is. So that is our final expression. I'll see you in the next one.